So now for the introduction, so as we can see right now, these are the standard grease trap that are usually implemented inside of food and beverages operators, and these grease trap are divided into few sub parts which will be need to be cleaned daily by these workers, and this process can get intensive and cost ineffective. So, municipal authorities in Malaysia also requires all food operators to install a grease trap inside their kitchen, and this is according to the Street Drainage and Building Act of 1974. And if they fail to do so, then these premises are obligated to pay a fine of up to 1,000 ringgit.
So, how a grease trap normally works? First of all, water from the kitchen grease trap will flow out through an inlet pipe. Then, grease that is less dense than water will float above the water, while food solid that is more dense than water will sink. Then, wastewater will flow out through crossover pipe into the secondary tank. Lastly, the wastewater will flow out through outlet pipe to sewage pipe.
So this is the manual way to clean a grease trap, and there are few procedures that are required to clean this grease trap. And for information, workers are required to clean the grease trap every day, and this process requires a lot of labor energy.
We move on to the problem statements, which are divided by three parts. The first part is pollution. Food waste mostly contribute to river pollution. Next, harmful odor. Most food waste consists of oil, melted fats, fat pieces, minced meat, and vegetable scrap that will produce foul smell after quite some time. Last one is high cost, because need to repair and maintain the clogged pipe due to solidification.
So, we are going to propose an idea in designing a smart maintenance system based on Internet of Things to do the maintenance service for the kitchen grease trap. Moving on to 5.0, our prototype comprises of 7 main components, which are lead acid battery, hose, water tank, Arduino, ultrasonic sensor, turbidity sensor, and centrifugal mini pump.
So how does our system works? So we have divided into 3 main components, which is the input, process, and the output. So for the input, we have the turbidity sensor, which is to check the quality of the water. And second, we also have the ultrasonic sensor to check the volume of the water. And these two sensors will collect the control parameter and send the input data to the Arduino. And second, for the process, we have the Arduino, which is going to compute the data according to the coding that we have implemented. And for the output, we have the centrifugal pump, which is going to actuate the water whenever the data received is controlled with the coding uploaded. And we also have the blink applications to show the data received from the sensors. So this is the flowchart on how does our product actually works.
Figure 1 shows the chart of turbidity versus voltage from standard TSW10 turbidity sensor. The results prove that the higher the turbidity of water, the lower the output voltage generated from the remaining light passing through the wastewater. Therefore, the sensor is used to determine the values of water turbidity for the maintenance monitoring system.
Next, for our research and findings of ultrasonic sensor data results, this graph shows the relationship between water volume and water level ADC. This testing proves that this ultrasonic sensor unit is working well to determine the water level of solution to prevent the overflow problem of sewage inside the grease trap.
So now for the third part of the research and finding, which is the wastewater removal efficiency from the grease trap. So the graph shows that the relationship between the water turbidity and time when the system operated. So when the turbidity sensor detects the lousy quality of the water, it will start to pump out the wastewater, hence lowering the turbidity value. And as a result, with the implementation of the automatic maintenance system, the wastewater removal efficiency stands at 81.64%.
So who are our customers? Our customers include restaurant, hawkers, household, and hotel operators. So the key partners in the implementation of our product are the Ministry of Housing and Local Government, Kuala Lumpur City Hall, and Indah Water Consortium Sendirian Berhad. Last but not least, our product has received numerous awards from various international competitions that we have participated in, namely is the IWIS 2020 Gold Award, ICIF 2021 Gold Award, I2Create 2021 Gold Award, and recently from last year, Malaysia International Young Innovators Olympiad 2021, which we have won 3 special awards during the competition. To conclude, our product is suitable to be implemented in any other countries as it is parallel to the 4th Industry or 4.0 revolution with the usage of Internet of Things, IoT that has been embedded.